All right, now we're doing 7Q, upper body strength. This is by Codewars, and 88% of the people like it. Alex is transitioning from website design to coding and wants to sharpen his skills with Codewars. He can do 10 kata per hour, but when he makes a mistake, he must do push-ups. These push-ups really tire poor Alex out. So every time he does them, they take twice as long. His first set of redemption push-ups takes 5 minutes. We're going to create a function, Alex mistakes, that takes 2 arguments, the number of kata he needs to complete, and the time in minutes he has to complete them. Our function should return how many mistakes Alex can afford to make. All right. So for this one, we're going to have to do some things, all right? Basically, we're going to have to subtract from the time limit the number of kata times the amount of kata he can do per minute, per hour. Something like that. I'll show you what I'm talking about. All right, check it out. So first things first, let's declare some variables. We're going to say let result equals 0, right? And the result's going to be the number of times we can go through. We can afford to do the push-ups. All right, and we're also going to have time left, which is going to equal the time limit minus the number of kata times, and since we're doing 10 per hour, we're going to say times 60 minutes divided by 10 per hour, and that's going to just equal 6. All right, and then, so that's basically the time limit. That's the time left. And then after that, what we're going to do is do the push-ups time. So it's going to be like 5, and then on the next iteration through, because we're going to be doing a while loop, on the next iteration, it's going to be 10, next iteration 20, and so on and so forth. So we're going to say the next thing is push-ups time, right? And it's going to equal 5 to start off with, right? So now we've got that taken care of. Let's do a while loop. So while time left is greater than or equal to push-ups time, we're going to say time left minus equals the push-ups time. All right, so it's just going to take that off of there, and then after that we're going to say push-ups time times equals 2. So we're going to multiply it by 2 each iteration, and then we're also going to say result plus plus each iteration, all right, to count the number of times we can do push-ups. And then we're just going to return result. Let's see what happens. All right, good. Attempt it. 6 milliseconds. All right, that seems like something we might be able to beat, maybe not with concise syntax. Let's see. So let's go back here, and we're going to change this function to const. That's not how you spell it. Alex mistakes equals this, and all of this equals this arrow right now. All right, so we're going to start on the next line because I don't have too much room on here, and we're going to have to use some math on this one. First thing we need to do is put this in like a math equation, right? So based on what we have right now, we have what is it? 2 times 2 to the x power equals something. So because this is how many times we can do push-ups, we're going to be able to do the push-ups. So 2 times whatever to the x, 2 to the x power equals, what does it equal? It equals the time limit minus number, that's not how we do it, number of kata times 6 all right, put that in parentheses, and all this divided by 5, because that's the initial value of the push-ups right there. And we have that. And so when we have 2 to the x equals something we actually have, we're going to have to find x somehow. So to find x, when x is an exponent, we're going to be using this binary logarithm. So we have this 2 times x equals n, and that to find x equals log 2 n. And luckily we have this log 2 function which returns the base logarithm 2, the base 2 logarithm of a number. All right? So we've got that going on. So we can basically write that out. We can just say here, math.log2 this. Let's put it in parentheses like this. But we've got a thing, okay? So let's do this right here, test it out. All right, and we also have to bring it down to an integer. So right with that, we're going to use the, what is that thing called? The Bitwise OR operator, all right? And the Bitwise OR operator returns a 1 anyway. It does that, but if you put 0 in this B place right here, and like have something that's point anything, and run it, it just does basically rounding down no matter what it was. Let's say it's 0.9, right? Run it, still rounds down. Awesome. So that's what we're going to do here. We're going to say this, the Bitwise OR 0, test it out. Oh, looks like it works, doesn't it? Attempt it. Oh, but it doesn't work. And the reason why is because it's not the thing we're doing. We're not really looking for this here. We also have to have we have to take into consideration the first go of it. So like on the other one, let's go back all the way. Like right here, you see how it's greater than or equal to push-ups time. Well, on that one, it's just that right now. All right, cool. So we got to change it over there. Oh no, we got to redo everything. Whatever. Anyway, we got to change it over there. Give me a second. All right. So now we're back to this. So to take care of that thing that I was talking about with the greater than and equals, we're just going to do this. We're going to use this Strahler number right here. And basically you have to read all the way to down here before you get to it. But because of these binary trees and stuff like that, what we need to use is this log 2n plus 1. All right, that's gonna find us the largest possible Strahler number. All right, so we're gonna do this. We're gonna say plus 1. Test it out. Okay, hold on. Oh yeah. Bitwise operator 0. Bitwise OR 0. Test it out one more time. Looks good. And we attempt it. When we attempt it, it works. And basically that Strahler number, when it gets to something like 4. If you read up on all this, once you get to 4 branches of a stream or a tree or whatever, it starts getting a little funky, and so you have to add this plus 1 for whatever reasons. Oh well, for this reason right here, if you want to translate math into stuff you can understand. So yeah, that's what works. We're gonna submit it. Oh whoa, 6 milliseconds. Okay, cool. So they're both the same. Very much like it. My solutions, just me on this one. Best practice, and we'll see you next time.